Welcome to Life Balance Central, where we bridge scientific understanding with practical living. In today's episode, we continue our special six-part series on metabolic health optimization, based on the groundbreaking research and insights of Dr. Casey Means. As a Stanford-trained physician and metabolic health expert, Dr. Means has revolutionized our understanding of how cellular health impacts our overall well-being. In this second episode, we'll dive deep into the fascinating world of cellular energy production and its profound implications for our health. Section 2, the cellular basis of metabolism, mitochondria and energy production. Inside every one of your 40 trillion cells lies a fascinating story of energy transformation, a process so fundamental to life that understanding it changes how we think about health, disease, and human potential. At the heart of this story are the mitochondria, often called the powerhouses of the cell. But these remarkable structures are far more than simple energy factories. They're sophisticated sensors that continuously monitor our environment and adjust our body's energy production in response. Think of mitochondria as millions of tiny power plants distributed throughout your body, with some cells containing just a handful, while others house thousands. Just as a city's power grid must efficiently convert various forms of raw energy into usable electricity, your mitochondria perform the remarkable feat of transforming the food you eat into a form of energy your body can use. In fact, these cellular power plants are so efficient that they produce approximately 88 pounds of ATP, adenosine triphosphate, your body's energy currency, every single day. A staggering amount that's constantly recycled and renewed to keep you alive and functioning. But here's where the story becomes even more intriguing. Mitochondria don't just blindly produce energy. They're sophisticated environmental sensors that make moment-to-moment decisions about energy production based on various signals they receive. Imagine each mitochondrion as a smart power plant that can adjust its output based on factors like available resources, nutrients from food, environmental conditions, temperature, light exposure, physical activity, and current energy demands, exercise, thinking, healing. This adaptive capability makes mitochondria incredibly powerful, but also vulnerable to modern environmental challenges. When our environment sends signals that our cellular machinery never evolved to handle, our mitochondria can become confused and inefficient. This creates what scientists call a trifecta of bad energy: mitochondrial dysfunction, chronic inflammation, and oxidative stress. Understanding this trifecta is crucial because it lies at the root of many modern health challenges. Let's break this down using a metaphor that might feel surprisingly familiar to Californians. Imagine your cellular health as a city dealing with three interconnected challenges. First, there's mitochondrial dysfunction, which manifests as rolling blackouts, not enough power to meet the city's needs. Then there's chronic inflammation, which acts like biochemical fear, creating a state of constant cellular anxiety and defensive responses. Finally, there's oxidative stress, which behaves like wildfires, causing damage that further strains the system's resources. When mitochondria become dysfunctional, they struggle to convert incoming energy, food, into usable power, ATP. This creates a cascade of problems throughout the cell. Think of it like a factory that can't process its raw materials efficiently. The inputs pile up, creating storage problems, excess fat, while the outputs, energy, remain insufficient. This is why simply eating less isn't always the answer to metabolic health issues. If your cellular power plants aren't working efficiently, reducing inputs doesn't solve the underlying conversion problem. The cell responds to this energy crisis by initiating what scientists call the cell danger response. Imagine this as a citywide emergency alert system. When mitochondria aren't functioning properly, they release distress signals, including ATP, into the space outside the cell, something that should never happen under normal circumstances. This is like a power plant releasing its fuel into the streets. It immediately triggers emergency responses throughout the neighborhood. This emergency response leads to inflammation, our second challenge. While inflammation is a natural and necessary process for healing, chronic mitochondrial dysfunction creates persistent inflammation that never fully resolves. It's as if the city's emergency services are constantly responding to alarms, never getting a chance to rest and reset. This constant state of biochemical fear further strains our cellular resources and can lead to a variety of health issues. The third challenge, oxidative stress, occurs when dysfunctional mitochondria produce harmful byproducts called reactive oxygen species. These are like sparks from a malfunctioning power plant that can cause damage to surrounding structures. While our cells have natural antioxidant systems to handle normal levels of oxidative stress, chronic mitochondrial dysfunction can overwhelm these protective mechanisms, leading to accumulated cellular damage over time. Understanding this cellular energy crisis helps explain why so many modern health conditions, from obesity and diabetes to cognitive decline and autoimmune disorders, share common underlying mechanisms. When our cellular power plants can't efficiently convert food into energy, the excess gets stored as fat. When cells can't produce enough energy to function properly, different tissues show different symptoms. Brain cells might struggle with focus and memory, muscle cells might feel weak and tired, and immune cells might become overactive or confused. The good news is that mitochondria are remarkably adaptable, and there are specific ways we can support their function. Just as a city can upgrade its power infrastructure, we can enhance our cellular energy production through targeted lifestyle interventions. The key is understanding what our mitochondria need to thrive and how to provide the right environmental signals for optimal function. Understanding these cellular mechanisms gives us a strong foundation for exploring practical interventions that can enhance our metabolic health. As we've learned from Dr. Means's research, our mitochondria are remarkably responsive to lifestyle changes, offering hope for improving our cellular health at any age. In our next episode, we'll explore key factors affecting metabolic health, movement, food, and environment, where we'll translate this cellular understanding into practical lifestyle strategies. We'll discover how specific activities, dietary choices, and environmental factors can optimize our mitochondrial function and enhance our overall metabolic health. Stay tuned as we continue this transformative journey toward better health and vitality.